How's it going, everybody? Welcome back to another Inventor VEX tutorial. Today we're going to discuss how in Inventor Assemblies we can take and attach wheels to our robot. Now this will be attaching wheels to the robot without a motor, so just kind of free spinning like this one is here, and then attaching wheels so that they fit inside of a motor right here using my best practices. So let's jump on in. I have got a chassis all started here. I've got some motors placed on. You can find out how to do the motors in the motor tutorial video. I've got some wheels here that have already had the shafts inside of them. And then I've got these shaft collars just placed where they gotta be. So we know how to stick, how to line up a shaft with a flat bearing. We have done that before. So for some refresher though, what we're going to do is, because the shaft has square geometry and it's lining up with a piece of round geometry, we have to find the axes that they both have in common. To do that, we need to find our shaft by clicking it in the model space and then locating that blue highlight on the model browser on the left side here and expanding it. Now we're going to expand it and see we have all this information. We're going to find work plane 1 and expand that, or we'll find work axis 1. We'll use work axis 1 as our axis. So let's go ahead and constrain that. So I'm going to constrain, open up my constraint window to place a constraint, select my work axis 1, and then I'll select the axis that I want it to line up with right there. Apply. Great. We have done this before, however, I have not yet shown how to get everything lined up here. So let me walk you through how I line things up. I first get everything on. So I'm going to get both of these shaft collars on here as well. To do that, we're again going to grab our work axis from our shaft and then stick these onto there. Now you notice that these clip into each other a little bit. That's okay. Bring that one this way, this one that way. So everything now is lined up. Nothing is constrained horizontally though. Let's take care of this shaft collar here. You can see how I have this shaft collar attached kind of to this piece of metal. That's what we're going to do. We're going to grab our mate constraint here, mate, and we're going to apply a mate constraint between that face of the shaft collar and this face of our metal. Great, we can apply. Now let's get our wheel placed all the way on over here. To do that, we're going to get the face of our flat bearing, which is already fully constrained, and then stack it next to that face of our wheel there. Let me show you that again. I will select this big face of my wheel here. Not a line, not the inside, this big face of the wheel there. And then the flat front of my flat bearing here. Apply. Now I can stack this on here. I'll grab the piece of my wheel there, and then I will rotate around a little bit, and I can find that face of my shaft collar. Can apply. So now everything's applied here. The only problem is that this can still translate in and out. Let's fix that. Let's set that in place. To do that, I'm going to use this face and that face with a flush. However, when I do it with a flush, watch what happens. It makes them totally flush together. If we see on our example on this side, we want them to be spaced out a bit. To do that, we'll go up here on our constraint box and we'll apply an offset in the offset window. That will move them apart ever so slightly. So what we can do is let's apply a 1/4 inch offset, or 0.25. Now watch what happens. It goes out. If let's say it went the other way, I can apply a negative offset by putting a negative in that box there, and it'll go the other direction. So 0.25 works just fine there. Apply. That's stuck on. This is fully constrained, not going anywhere, and you can see what's nice is the wheel still spins, which is pretty slick. Now that was easy. Getting these into a motor is a bit more tricky. And it's tricky for a couple reasons. First, there's a few more steps. And second, it's hard to see things. Because at some point, we're going to have to be able to see into our motor inside of there. Our motor inside of it, in fact, let me hide this piece real quick here. Our motor has a face all the way inside of there that we have to grab. So that makes it pretty difficult to get in there. And what you just saw me do was I changed the visibility. So what's nice is we can turn pieces on and off like a light in Inventor. So we can just tell them I want to see you and tell them I don't want to see you, and it's pretty handy. So let's get, first and foremost, let's get our wheel lined up with the right spot on the bearing. Again, I'm going to grab the shaft. On my model browser here, I'm going to expand it. I'm going to expand work plane 1, find my work axis 1, open up a constraint, snag work axis 1, and then snag the shaft in which I want to put that flat bearing. Snag the piece, the hole where I want to put that shaft. And I know that one's this one. I'll hit apply. So now this is all lined up nicely here. Now, in order for me to find the point at which this will go in and out, or will get set in stone there, I need to find the end of this motor, right? Where that square kind of meets up with the other square all the way inside of there. The problem is I can't see that very well. So I'm going to change my visibility. Let's select this piece of structure there. What I can do is I can right-click that structure, and I get my wheel and my right-click menu that opens up. On this wheel, I have a little button that says visibility and a little check. I'm going to uncheck that. Great. So now it's still technically there. However, we just can't see it, so it makes life a lot easier for us. What we're going to do next is we're going to constrain the back of this all the way inside of there. I used the view cube and I clicked and dragged it just slightly so I could see that all the way inside of there. I'm going to grab that face. This is where you want to be particularly careful that you're grabbing the face and not a line. This face, I'm going to flip around. I'm going to select this face. Apply. So now that shaft is in place. The order in which I do things doesn't matter so much right now, just so long as you have all the constraints put on there. So let's get our C channel back in. Now to bring something back, there's nothing to click here, right? It would be right there. There's nothing to click. On my model browser, I can kind of paw through here and see how all of these cubes are solid blue. I've got one that is not. That's sort of this transparent, and it's now white, black and white. I can right-click that, and then I can scroll down to see visibility, and I can click visibility right there. And now we're back. We're all good. So next, let's get these shaft collars on there. To do that, I'm just going to do what I do for all of these, which is to get that shaft, find the work axis, constrain that work axis to the axis in our shaft collar. Apply. Now let's do it again for this other one. Grab work axis 1 there. Grab my shaft collar. Apply. Great. Now everything is on here. It's just kind of moving around in funky ways. Let's stack all this up. Now in my example on this side, you can see I've got a shaft collar here, and then a shaft collar there, and then I've got my wheel sandwiched between the two. Let's do the same thing. Let's get this shaft collar mounted up against here. I'm going to pull it away so I can see it when I turn around. I'm going to open up. I'm going to make sure I have a mate constraint. Use that face of that piece of C channel in this face of the shaft collar. Apply. Great. Now let's get this wheel sandwiched on there. Grab my flat bearing, mate that with this face of my wheel. Remember, be very careful to select the right face. Apply. Now I can grab this piece of my wheel. And then this can be kind of tricky, so I'm going to grab my view cube and drag it to kind of see a bird's eye view. That face. Now we're good. So now this wheel is still able to turn, which is kind of handy. That's not super important, but it helps. And it's all fully constrained. Nothing's moving anywhere where it shouldn't be. So I've gotten two different wheels on. I've gotten a wheel that is not attached to a motor put on, and I've got a wheel that is attached to a motor put on. And putting it on the motor was quite a bit harder because I had to line it up inside the piece of the wheel, and then I had to hide some things using that visibility tool. So, however, with some practice, you can get pretty good at it. So, it is not an issue when you practice. As always, let me know if you have any questions. This is all I got for you in this one, so I will see you in the next one. Thanks.